We're asked to find the point on the parabola that's closest to 3, 0, so right here. So we need to create an equation for this distance, because maybe the point P is supposed to be there, maybe it's supposed to be up here, maybe it's supposed to be over here. So to create that equation, you could draw yourself a right triangle and then use the Pythagorean theorem. Let's see though. From here to here. So we don't know this point. We'll call this x comma y. And so the distance between here and 3 comma 0 could be found by using the Pythagorean theorem for the diagonal here. So this distance from here to here we don't know. It depends on x. It's going to be the difference between those two. Oops. Because let's say x was 2. Then this distance is 1, right? Because 3 minus 2 makes 1. And then same thing up here. We don't know this distance because it depends on where we choose our point P. But we know it's going to be y minus 0. So we can just write y there. And so the Pythagorean theorem says a squared plus b squared equals this c squared that we're trying to solve, that distance. We're trying to solve for that distance, and then we can minimize it with calculus. And so you might recognize this is turning into the distance formula. If you learn the distance formula in algebra, it's not a topic that's always covered. That's all the distance formula is the Pythagorean theorem. Because I'm taking a square root to cancel out the squared, and technically we should have positive or negative, but we're not worried about negative distance for this problem. So c squared is this entire square root. So we can't take a derivative right now because we have a y and an x, but we can replace y with x squared. So that's y squared. So we got x squared being squared, so that's x to the 4th. Now we have an equation just in terms of x. And this is what we want to minimize, so we'll take a derivative. So this is the square root is a 1/2 power. So when you take a derivative, the 1/2 power comes down. Everything on the inside stays the same. The power gets reduced by 1, so this is now negative 1/2. And then we need to use the chain rule. Then we multiply by the derivative of the inside. So the derivative term by term, this is going to be 2 times 3 minus x, and then the power gets reduced to 1, but then this derivative isn't over because you need the chain rule. The derivative of negative x is negative 1. And the derivative of x to the 4th is 4x to the 3rd. Okay, so we took a derivative of the outermost function, the 1/2 power, took a derivative of the innermost function. Looks like we're done now. That's what the derivative of c is with respect to x, and we need to set that equal to 0 to find critical points. So remember, a negative 1/2 power, this is like in the denominator of the fraction. That might help you rewrite it, but what I would do first is I'd multiply both sides of the equation by 3 minus x squared plus x to the 4th to the 1/2 power. That way, when I multiply here, it makes 0. And then I chose the 1/2 power so that when I multiply it here, negative 1/2 power times something with the 1/2 power, the powers add to make 0. So this is now just 1. Still get the 1/2. So backing up here, this is supposed to be 0. The whole point of using this term was to make this be 0 power, so that's 1. And then here, this is negative 2, because that's 2 times negative 1. 3 minus x plus 4x to the 3rd. So I got 1/2 times negative 2, that makes negative 1. And then we got 1/2 times 4x makes 2x. Then we distribute the negative 1. That's a 3rd power. So when it's a 3rd power, we don't have nice ways of factoring like we do when it's x squared, but you could use something called the rational zeros theorem if you want to do this without a calculator. But if you look at it for a bit too, you might be able to spot it. X equals 1 is going to be a solution to that equation because -3 plus 1 plus 2 is going to make 0. So x equals 1 is a critical point, and if you test it, it will be the minimum that we're looking for.